Chapter 12, Section 4 discusses diagrams called phase diagrams. But before we get to that, we need to do a little review of changes of state. Remember, evaporation is going from a liquid to a gas state. Condensation would be the opposite, going from gas to liquid. And then sublimation is one people aren't necessarily as familiar with. That's when you go straight from a solid to a gas without going to the liquid state first. So things like mothballs or dry ice, those can go straight from the solid to the gas form. And it's called deposition, going in the reverse direction. Another term you need to know is vapor pressure, and that's the pressure that's exerted by a gas or a vapor in equilibrium with its liquid state at a particular temperature. So these surface particles here that are in the liquid form will be evaporating, and that pressure that they give off will be that vapor pressure. A phase diagram then is going to be a graph that shows temperature and pressures at which a certain substance exists in different phases. So every different substance is going to have its own phase diagram. Phases are at equilibrium along the lines of the diagram, and a phase itself just means the state of matter that it's in. So when the substance has complete uniform composition and properties, so it's a solid, it's a liquid, or it's a gas. Here's one example of a phase diagram. You can see the temperature here on the X and the pressure on the Y. And they all have this kind of Y shape to them. To the far right is going to be the gas, to the far left is the solid, and then in between will be the liquid state. So these lines are going to represent the places where they're at equilibrium. So where you're going to have solids becoming gases, gases becoming solids. This line would be solids becoming liquids, liquids becoming solids. And so on. There's also a couple other points that we're going to be discussing. There's this point right here where all three of these lines meet, and then this point at the end of the line between liquid and gas. A couple other points that are also important. The normal boiling point, which is going to be the boiling point or the boiling temperature at 1 atm of pressure. So if you follow 1 atm across to where the substance would be boiling, so going from liquid to the gas state, this point right here, whatever temperature that's at, that is going to be the boiling point, and that's the normal boiling point because it's at standard pressure of 1 atm. You could say the same for melting point. The normal melting point would be if you follow 1 atm across to where the solid would melt into the liquid state, and that would be the normal melting point since it's at 1 atm. The critical point is the temperature, the point where above that you can't tell whether it is a liquid or a gas. It is called a supercritical fluid. So this point right here at the end of the line between liquids and gases, anything above that temperature or pressure wise is no longer on the graph, and we can't distinguish the properties between those. So we just call it a supercritical fluid, which some of these have a really great ability to dissolve substances. And then the last point is the triple point, and that's where all three phases are in equilibrium with one another. Okay, so this one here is the phase diagram for water. This is our triple point where all three of the lines come together. Our normal melting point, if you follow it across, our normal boiling point, and then this is the critical point at the end of that line. This is the phase diagram for carbon dioxide. So you can see a different substance, still the same basic shape for that particular substance.